This is lesson 232, the Pythagorean theorem. So we have these triangles down below. They are all the same. We've got 4 of them, and they've been rotated and positioned so that they fit in the box like this. Okay, so this is what they look like now. We have 1, 2, 3, 4 of the triangles. Okay. The area of the unshaded square in the middle. All right, well, we have C, that is the edge of this triangle, and that is the same all around. And this is a square, and we know that the area is base times height, or length times width, or side times side for a square. So the area of this square is C squared, right? Since that's C times C. So then the triangles were rearranged to look like the picture on the right. And they are asking us if the unshaded region would change, okay? So this unshaded region right here, we're going to shade it green. That turned into this, and they're asking if the area stayed the same. And of course the answer is yes, because we still have the same 4 triangles. They're still inside the same box. The area just looks a little different, but it is the same unshaded area. So here is the Pythagorean theorem, okay? If we looked at the original sides, the shorter sides are B, A, B, B, A, B, A, and A, okay? And then this is C. I'm sorry, this is A and A, and this is B and B, okay? This shaded region right here, let's say in the red, okay? This has an area of A squared, right? This is A times A, so that's A squared. And then this shaded region in the green over here is B times B, B squared, okay? Now, because we said the area of the unshaded region didn't change, it was C squared, and it turned into A squared and B squared. So here is the Pythagorean theorem. A squared plus B squared equals C squared, okay? I'm sure you've heard this formula before, but maybe you've never used it or didn't know what it means. And we just kind of derived it for you here with some triangles. So let's go ahead and apply it. This e-tool you'll use in class, it's not really worth going through in the video, okay? But essentially, in a triangle, your longest side of the triangle, the side that's across from the right angle, is always going to be C, okay? Longest side, and we actually call this the hypotenuse. The longest side of a triangle, or the hypotenuse, is always C in our equation, okay? And it'll always be across from the right angle. It'll always be opposite from the right angle. And then the other 2 sides, A and B, it doesn't really matter, okay? We could have A and B like this, or A and B like this. A and B are interchangeable, okay? A and B are interchangeable. That's basically the takeaway from the e-tool, okay? So let's go ahead and apply this. Let's go ahead and label our sides. That's a great place to start. I know that my longest side is C, so in that case that is X. And then again, I can make whichever one I want A and B. So when I write the equation A squared plus B squared equals C squared, I can plug in my A, my B, and my C into this equation. So A is 4, so I'm going to have 4 squared. B is 5, so I'm going to have 5 squared. And then C is X, so I'm going to have X squared. Now, when you are squaring a number, that is taking the number and multiplying it by itself twice. So this is really 4 times 4, right? This is 5 times 5, and this is x times x. That's what's going on there. And of course, you can always punch these into your calculator as well. 4 squared is 16. 5 squared is 25. And then x squared is x squared. We want to solve for x. We want to find what this missing side is so we can draw our line. 16 plus 25 is 41. So now we are left with x squared equals 41. And we talked about in the beginning of the year how to undo an x squared. And the way that we do this is we take the square root of x squared, and that square root undoes the square, okay, or to the power of 2. And if we do something to one side, we have to do it to the other. So we're going to square root both sides. So then we're going to be left with x, right, because the square root and the square undo each other. And then you can type the square root of 41 into your calculators. That is not one of the nice ones, so you probably don't have that memorized. It ends up being 6.4. And there's a lot of decimals after it. We can just round it to 6.4. So that's what that side should be, 6.4. One way you can check if you're right is to make sure that your answer is always longer than each side, okay? Because it should be the longest side. It's the hypotenuse. All right, we're going to try another problem here. We're going to start by labeling our sides again. The longest side across from the right angle is the hypotenuse, so this one is C. And then again, A and B are interchangeable. So here I have A and B. So when I go to set up my equation, A is y, so y squared plus 7 squared equals, C is 11 this time, so 11 squared. I'm going to go ahead and simplify. Y squared stays y squared. 7 squared is 49, and then 11 squared is 121. In order to get y squared by itself, I can subtract 49 from both sides, so that y squared equals 72. And again, same as before, in order to undo a square root, in order to undo a square, we need to square root, and we'll have to do it to both sides, okay? So, of course, the square root of y squared is just y, and the square root of 72 is 8.5. I'm rounding up to 5. There's a bunch of decimals after, but 8.5 is good enough for us. And that should be about right. It's less than 11, so we are good to go. All right, we're going to look at the rectangle to the right, find the perimeter and area, okay? They gave us 6 here, so that means the bottom is 6. But in order to find the area and perimeter, we need to know this set of sides, and we don't know that. But we are given this line that cuts through, okay? And we need to know the pink side. So what I can do is I can look at this as a triangle that has a right angle, where I know that this side is 6, the hypotenuse is 15, and I am looking for this side on the left here. And we have a Pythagorean theorem problem. So again, I'm going to label my sides. The longest is C, and then A and B are interchangeable. I'm going to set up my equation. A squared, so 6 squared, plus B squared equals C squared, so 15 squared. If I simplify, this is going to be 36 plus x squared equals 225, okay? And then I can subtract 36 from both sides to get 189. And then, of course, my last step is to take the square root of both sides. And I'm going to get 13.7. 13.7. So that's this side right here. Now that I have all my sides, I can find the perimeter and area. So again, perimeter is adding up all the sides. So 6 plus 13.7 plus another 13.7 is going to get me 39.4. This is millimeters. And then my area is the base times the height, or the side times the side. So this is 6 times 13.7, which is 82.2 millimeters squared. All right, we are going to draw AC down on this graph. The coordinates for AC are 2, 6, and 5, -1. So 2, 6, this is A up here. And then 5, -1, this is C down here. Okay, they want us to draw a slope triangle. Now, if you don't know what a slope triangle is, it's when we draw the distance that these 2 points are going up, down, left, or right. So starting from the left, because we read graphs like a book from left to right, we are going to go down to get from A to C, and then to the right to get from A to C. So this is what we call a slope triangle. I'm going to count how many places we went down. 1, 2, 3, 4, 5, 6, 7, 8. So we went down 8, and we went to the right 3. So this is our slope triangle, which is basically a right triangle that we could find the length of AC for using the Pythagorean theorem. Okay, so 3, 8, and we don't know AC. So again, we're going to use Pythagorean theorem. I'm going to label my sides A, B, and C. So 8 squared plus 3 squared equals C squared. 64 plus 9 equals C squared. So this is 73 equals C squared. I can take the square root of both sides, and I'm going to have to use my calculator for the square root of 73. But I end up getting 8.5 as C. So this distance right here, the length of AC, is 8.5. All right, we have a word problem over here, but don't be scared. The Garcia family took a day trip from Cowpoke Gulch. Their online directions told them to drive 4 miles north, 6 miles east, 3 miles north, and then 1 mile east to Bighorn Flat. They want us to draw a diagram and calculate the direct distance from Cowpoke Gulch to Bighorn Flat. Okay, we're starting at Cowpoke Gulch. Okay, so let's start down here. Cowpoke Gulch. There we go. They are driving 4 miles north. So let's go up about 4. 6 miles east. East is to the right. Right? Never eat soggy waffles. There we go. And then 3 miles north. So we're going to go up 3 and then 1 mile east. Okay. And they want to know how they could just drive straight there. And then that's where they get to Bighorn Flat, right? So they just want a straight path, and they want to know how long that would be. So it's not a very good drawing for me, okay? But basically, we have 2 triangles here. Let me fix that part for us. There we go. That's a little better. Okay, so we basically have 2 right triangles here. Okay, so what we can do is we can find this distance, the hypotenuse of this triangle, and then this distance, the hypotenuse of this triangle, and we could add them up and find the total direct distance. Okay, so this first triangle down here, this is going to be 4 squared plus 6 squared equals x squared. So 16 plus 36 equals x squared. 16 plus 36 is 52. So the square root of 52 gets us 7.2. And then this triangle over here, 3 squared plus 1 squared equals y squared. So 9 plus 1 equals y squared. That's going to get us 10. And the square root of 10 is 2.7, about 2.7. So this section right here is 7.2, and this is 2.7. So what we can do is add those together. 7.2 plus 2.7, that is going to be 9.9 roughly. Okay, so it's going to take them 9.9 miles to get straight from Cowpoke Gulch to Bighorn Flat. All right, we will move on to the check your understandings. Okay, here is our C, our A, and our B. So setting up an equation, 3 squared plus 4 squared equals C squared. It's going to be 9 plus 16 equals C squared. And then we can take the square root of both sides to get that C equals 5. With this triangle, we have A, B, and C. So 7 squared plus B squared equals 10 squared. So 49 plus B squared equals 100. 100 minus 49 is going to get us 51. And then we can square root both sides of that equation to get 7.1. Over here, we have our C, and we're missing B, so 2 squared plus B squared equals 3 squared. 4 plus B squared equals 9. And the square root of 5 is 2.2. Over here we're missing our C, so our equation is going to be 8 squared plus 11 squared equals C squared. 64 plus 121 is C squared. And then the square root of 185 is going to be 13.6. Moving on to the medium where we have 6 and 3, we're missing our C. So 3 squared plus 6 squared equals C squared. 9 plus 36 equals C squared. This is going to be 45 is C squared. And we can take the square root of 45 to get that C equals 6.7. Over here we have A, B, C. Just a quick reminder, it doesn't matter which one's A and which one is B, as long as C is the one across from the right angle and it's the longest side. So 2.5 squared plus B squared equals 3.2 squared. So 2.5 squared, 6.25 plus B squared, and then 3.2 squared is 10.24. I'm going to subtract 6.25 from both sides, and that gets me 3.99. And the square root of that is 1.99, roughly. And then here we have our C, and we're just missing one of our sides. So 4 squared plus B squared equals 5.4 squared. 16 plus B squared. 5.4 squared is 29.16. We could subtract 16 from that, and we have B squared equals 13.16. And then, of course, taking the square root from both sides, B is 3.6. And then spicy. This is the same. These are all the same down here. But then we have this extra piece. Do the 3 given sides form a right triangle? So what we can do is plug all of these into our equation and see if that's true. So we've got A, B, and C. So does 7 squared plus 7 squared equal 9.3 squared? Let's check. This is 49 plus 49. And then 9.3 squared is 86.49. So obviously this is not going to work out. 49 plus 49 is 98. And that does not equal 86.49. So no. This one, 4 squared plus 6 squared, does it equal 8.5 squared? Let's take a look. 16 plus 36. 8.5 squared is 72.25. Obviously not, okay? This is going to be 52, and that obviously does not equal 72.25, so no. All right, let's see if this one works. It's already not looking too good for us. 4 squared plus 7 squared equals 8.1 squared. Does 16 plus 49 equal 65.61? Obviously not. None of these work out and form a right triangle because when we plug them into the